So maybe starting with a short little story. Back in 2008, I was able to, working with my chair, get some philanthropy to get this new device called AlignRT in our clinic. I think it was just FDA cleared. I'm not sure anybody was quite using it yet. And we got it installed. That's a whole story I'll tell you over a drink of how that happened. It was amazing. But it was installed, and it didn't quite work, right? You know, we turned it on, we were looking at patients, and then some of the key folks from Vision RT came out and said, well, what's wrong? Why isn't this useful? Well, I said, we need to be able to watch patients in real time, just taking a picture and then trying to match that patient to the picture that you took, which is how the system worked originally, wasn't quite getting it done. We need to turn the system on and have it watch the patient. And as story has it, you can check with Vision RT on this, the engineer on the way home wrote the code to monitor a patient in real time on the flight from San Diego to London. Fast forward, we were saying, oh, we can use this for SRS, and let's try to go ahead and do that, and then the rest is history. So from 2008, where there was one, maybe two or three systems, to 2016 when there were 800, up to 2020 when there were over 2,000 for other different vendors. That's kind of some of the backstory on SGRT and why the task group report when this started back in 2015, 2016 was, okay, this is something that's needed at this point. There were 800 users, and we had enough collective knowledge and experience to provide some useful advice. So the task group report was recently published in MedPhys in April 2022, so it's hot off the press. And I urge you all to download it and check it out. And these are some of the key, or all of the authors. Some didn't have pictures, so I couldn't get all the pictures. A couple of people I wanted to point out. Dr. El Halak was the chair of the task group and the first author, and did an amazing job in bringing this together. And then, of course, Vision RT's own Dr. Waghorn was part of the consultants that provided expert insight or information from the vendors as well. So the task group report consists of 7 broad areas: an introduction, background, commissioning, and QA implications, and then it goes into some specific workflow recommendations. There's a risk assessment component to it, and then talks a little bit about emerging clinical applications, and then some key recommendations. So I'll quickly kind of go through these just to give you that bird's eye view of what's in the report and where you want to look. The nice thing about the report is that it's very readable, and it's going to be useful for folks whether you've never touched or thought about an SGRT device. The introduction and background is perfect for you because it talks about some of the technologies, where it came from, how it works in a very broad sense. So it gives you that kind of background. For more experienced users, it could be useful just to round out your knowledge about how the different systems work and what options are. The background then also includes an equipment overview. There had to be a timestamp on it, so anytime you're writing something, it ends at some point. So between June and October 2019, tables 1, 2, and 3 give the specifications of the equipment configurations and interface capabilities and system performance for the different SGRT systems that are out there, obviously including Vision RT's AlignRT camera. Quick interlude here. So this is not in the task group report, but because of the audience, I thought you'd be interested in some of the updates. So Ben and I had exchanged some emails. So since the task group report, they released the Horizon camera for inbore, which you heard about from Dr. Kissling, a SIM-RT product. There's full field of view capability in some of the cameras that they have coming out now. Positional and motion accuracy have been improved to less than 0.5 millimeter and half a degree, and frame rates are increased as well. So those frame rates are important because that gives you that sense of like real time looking at the patient constantly. So the higher the frame rates, the better that off you are. And so the technology is constantly evolving and constantly getting better. So talk to your Vision RT reps to get the latest and greatest from them as you think about adding SGRT to your clinical workflow. So part 3 of the report is the commissioning QA. So several years ago, TG-147 was published. This is QA of non-radiographic localization and positioning systems. So much of the recommendations in this task group report are from TG 147. So that everything you've learned from TG 147 is not obviated, that's still relevant. And the SGRT task group report will pull out some of that key information that specifically focuses on how TG 147 applies to SGRT systems. Step 4 is, or section 4 is the clinical application. So there's a number of workflow recommendations for different disease sites. There's a short description about how to use this for head and neck, a little bit for extremities, but it does the task group report does a deep dive on whole breast and chest wall, DIBH, and SRS. So if you're treating these sites already with SGRT, you'll get some good either reminders or things you haven't thought about. If you're new, it'll walk through you step by step on how to take an SGRT system and implement it for these different disease sites. And this covers some of the key aspects around SGRT, determining that region of interest, what to include, what not to include, when to use X-ray imaging, and how to compare that to the SGRT system, and then common pitfalls. So very practical clinical advice on how to implement SGRT in your clinic. There's also a risk assessment section, so we talk about process mapping. There's an example of a DIBH or example of an SGRT process map, I think is for DIBH, and there's failure modes effects analysis in there that you can review to see some of what the group thought were the typical failures that you could see either from the system or from the workflow in your clinic, and fault tree analysis as well. And then section 6 is emerging applications. So there are things that SGRT is enabling. We just heard from Dr. Pogue about the Cherenkov approach that's kind of in that SGRT space. There's collision detection that can be facilitated with an SGRT system. Biometrics we know, so patient recognition, either facial recognition or just recognizing a particular body part. There's been work published on that, where SGRT systems can be used kind of passively just to observe a patient setup and to tell you whether it's the right patient or not. Really interesting work. And talks about some of the workflows that are being used in some clinics but are not as pervasive as breast and head and neck and cranial SRS types of treatments. So these are all the emerging applications of SGRT that are included in the report. And then lastly, key recommendations. So there are specific workflows for free breathing breast, DIBH breast, DIBH post-prostatectomy, and then how to use that with bolus, how to use the SGRT system with bolus effectively, and then cranial SRS, which is a staple for many clinics as well on using SGRT systems. So you could take this report and just read the introduction and background and get this high-level view of the systems. If you're already using it, you can go right to section 7 and check out these workflows, and then go back in the document and fill in any blanks or questions that you have in reviewing these workflows. So it's a very useful kind of user-friendly document that is very clinically relevant for patient treatments. And then the last thing that the document I thought does really well is point out the qualified medical physicist responsibilities in SGRT. And again, this is collective knowledge from everybody on the task group and then folks that we have talked to, and some of the things that the physicists should focus on when they're implementing SGRT in their clinic. Of course, it's the basic stuff: configure, commission, set up your QA program, et cetera. But also, it really emphasizes the importance of providing guidance to the physician and the therapy team, because you understand how the systems work, where the algorithms become unstable, and you might need to step in to make a clinical decision in real time. So the more that the physicist is integrated into the care team in driving some of these implementation and decision-making processes, the implementation and the use of the SGRT system is going to go much more smoothly. So we really encourage kind of pulling out these key physics responsibilities and working with those and your clinic in order to get SGRT implemented efficiently and safely.